research paper titled with From Landmarks to Language, Ultra Lightweight Phoneme Detection for Real-Time Lip Reading. So let's see an analogy where you are in a noisy train station or in a hospital room where speaking loud could compromise the privacy. So what if computers could understand the speech, not through the sound, but reading your lips? So this is the promise of visual speech recognition. So here is can be a problem that current system try to look at every single pixel of our mouth but frame by frame, so it's little bit reading a novel by memorizing all the words, so it can work but it is too slow, heavy, and it needs powerful machines, making it impractical for the lightweight devices. So our approach is basically different from the traditional work. Instead of starting at every pixel, we only look at the landmarks, the key points on your lips and the face, and then about 40 of them. So thinking of it, connecting all the dots as an outliner and painting at the entire picture as a frame. So this reduces the workload, and once we have the dots moving across the frames, we need to understand that what they actually mean. So there is our model comes that the RNN model, which is basically a memory driven note taker, and it doesn't see on one frame at a time. It basically remembers that how lips move from one frame to another, or one frame to the next one. So that's crucial, that speech is not just a shapes, it's a motion, it's a movement over time. So by extracting all the 40 k facial landmarks per frame, we drastically reduce the data. Then lightweight RNN, LSTM, and the GRUs analyze all the movements of the phonemes, and then it works as a smallest building blocks of our speech. So methodology wise, what we did, we take a video and then break it into some frames, and extract the lip and the tongue position and build a data set of the phonemes, and then train to model LSTM, and then you can say the GRU to compare the efficiency. So here can be a question that why phonemes, because working at this fine-grained level, phonemes can be more interpretable and more flexible for this one. So we train these models to detect the phonemes, like there can be another language, we can smallest one, that P, B, and R. So it's similar to teach the system the alphabet of the spoken language. So once the computer recognizes the phonemes, we learn them to predict the text onto the mobile phone. And of course, there can be a challenge that some identical words or identical alphabet can be there. So like P and P. So overcome this one, the LLM model helps us to diminish the ambiguity. So the result is basically biology inspired and computationally efficient for lip reading system. And our vision is totally clear that a fast and lightweight and the practical lip reading system that can work anywhere, to accessible for the hearing impairments people, then enabling silent communication in noisy environments, and strengthening the privacy in sensitive devices.